you guys confirm if you guys can see
Yeah.
the module 2? Yes, yes, yes. Okay. So we're gonna start from the beginning. I thought that the question. Sorry for that. Okay, so today the activities will be pretty much do the second week assignment. We're gonna do it together. I'll explain some of those comments for you guys, and we're gonna try to do the exercise together. So something that we're gonna change a little bit on this week assignment. This actually makes my life way easier for correcting. So if you guys can make a Word doc like this and print stuff, that would make my life so much easier, and you're gonna get your grades faster. So please, if you can do, that's great. Just your name, year, and the name of number of the activities on the top with whatever results you got. That's going to be enough. Okay, so I can evaluate faster your assignments. So that's going to be the approach for today. For the sake of time, I'm not going to do the print screens like I did for the last class. I want to cover more content with you guys. So that's what we're going to try. Okay. So today we're gonna talk about NumPy and Matplotlib. Those are two really famous libraries on the machine learning world for dealing with numbers. Okay. Arrays, and they are super fast. They're super useful. So yeah, that's the goal. To start, let's check our environment. Okay. So let's try to run those commands on the command line. In order to reach the command line, just search for command or CMD, just type CMD, you're gonna be able to open this. And then we can do similar to what we've done on the last class. You can do dash dash V, you can use dash capital V, and you're gonna check if you have Python installed. If you do, now check if you have pip installed. What is pip? Pip is like a Devis package management tool, and that's going to install the libraries that you might not have on your computer. Okay, really similar to how npm works. That's like the version in the Python world. Okay, so here when we run in pip list, we can see some stuff that I have installed because I gave this lecture to just before you guys. I have the NumPy and Matplotlib here installed. And in order to install any package, you just come here and type pip install and the name of the package. So if you guys can do that now, that would be great. Just run pip install NumPy. And if you have any doubt regarding the command that you should run, if you follow the instructions, you're gonna find this here, so you can just copy and paste as well. Okay? Yeah, so that's how installing libraries work. So I would suggest you run.
Can you start again? Because I have Python, but I am not sure about the pip part.
Okay. So those are on the syntax. If you go on content, I'll even view as a student now to make sure that you guys can see. Go in content. Sorry? module 2. Okay. Can anyone else, can you see? Okay. Are you on the correct section, like, I don't know.
Section 4?
Yeah, section 4. It should be section 4. Huh?
Just showed up now.
It's showing now? Okay. Yeah, maybe that was a refresh. So just go there, you're gonna be able to see the instructions there. And if you have any environment issues, I'd say for the sake of time, ask for someone that has things set up because today is going to be long, so I would recommend to do that for the sake of time. You can follow along. You're gonna pretty much do the same activities on your own as soon as you fix this environment. Okay. With that, where was I? Okay, so I was on the installation, so you can just run pip install numpy, just to make sure that you have things installed. I have already, it doesn't hurt to run it again in my case, but yeah, in your case, you're gonna see an output that's slightly different than this, okay? You're gonna download some stuff. Now, let's talk about the idle lib. We didn't really talk about that on the last class, but if you run this command, you can see the idle shell here. They have their own window. You can open files here. You can run files and things like that. If you prefer this window instead of the terminal, feel free to use that. Something interesting that I'd like to mention about this is that this was built in Python. So you can build a Windows interface or Macintosh interface just using Python language if you wish. Okay? In my case, I'll just use the terminal because I'm here, so why not? And I will run Python to open that window there. Okay? So in order to make sure that your environment is fine, let's run a few commands here, okay? So the first one is going to be import numpy. If you do an import numpy and everything works, that means that your environment is okay. You install numpy and everything is fine. If not, okay, I'll try for you. Anyone else is having issues with the installation? Okay, I'll try to help out there. You can work from there, but something that's important is to run pip. I will try to run pip like it can be working. No, pip like confluence, like pip. It's not going to show like that. You have to run it. That's only the space dash. Yeah, you have something there, so if you just run pip install numpy, that should work. Just follow the instructions of the sentence. You have to put in something else to follow along. Me too today. Okay.
So why it doesn't work in my PyCharm? Here it works. Terminal, but not this.
there are certain configurations that you can do. Follow along through the terminal. I think it's easier. Yeah, just for the sake of time. And yeah, so that's the thing. This is the Python itself. It's not the terminal, so you need to open the terminal, like standard terms. The pip only works on the terminal, guys. So if you open Python, that's not part of the Python. So the pip won't install anything new. Okay?
Actually, yeah.
Yeah, try
Here
to
it's
run
working, but not in my
slow. Okay, yeah, the link is as soon as you type Python, that's not the terminal anymore.
Otherwise, my just here works.
I need help. Everybody else has installed, and is it working or no? No? Okay. Huh? Stop? Okay. Now it's installing. Okay.
It's a mix of fun stuff. I did it for
Now you are outside the terminal. So yeah, that should work. Do you have ways of stuff? This is a Mac, right? Do you have home brew?
Do it for 5 minutes, trying to just see if it's good. Yeah, 5
Yeah, you really need to run. Do
Now I think we're working
yeah, for sure. I know how to fix, but I need to show the commands that will take a while. The colleague there is going to help, okay? Okay. Anyone is working? If they have errors, they should run
How do I? Yeah, small question. I don't know how to stop the reading for the more things. I just can only keep pressing enter to run it.
Okay. Yeah, that's actually how the help works. So you can read stuff and learn from it if you want. If you want to exit, you can just press Q, and that's going to leave.
Thank you.
Okay.
Yeah.
Okay. For those who managed to install and have everything ready, I'll run a few commands to test with you guys. So the first one is the import. That's easy, right? Something important about this command is that they have these S and P. This is not a requirement per se, but it's a really common pattern. anyone that any code that's related to machine learning, you're gonna see that. Everybody, instead of using type NumPy as the module, they just type np, whatever command that's inside that module, okay? Other languages, they have that functionality as well. Let's say SQL, you can change names of columns and things like that. In Python, you can do that with the imported libraries, okay? And that's called alias. We can run the help NP, and then we're gonna be able to see the explanation of how the NumPy works and the libraries and functions that they have available. If you want to exit this screen, you press Q, and Q like the letter Q on the keyboard, that should leave, and you're gonna go back to the screen. You know you're free and everything's working if you press enter, and you can see that you can move. And another comment that's important regarding this is that, remember that I mentioned that this was alias. So when you make help NP, it's not searching help on NP, it's actually help on NumPy. Because in the code, they are running NumPy, yes?
It says Q is modified when I try.
Control C should. Yeah, it's just for X. It's just for X. Yeah, so that's just for X. Don't need to run Q. Q is not a command. Yeah. If that doesn't show because you're the idle, don't worry. When you are at the terminal, that should show. That's just for showing the command. That's not part of the assignment. Okay? The activities are. Right now we are testing if our environment is okay. Okay. So let's run this other import as well. Yeah. Thank you. Okay. So what does that dir does? That pretty much says all the libraries and things inside NumPy, because that's what we passed as parameter, and dir, right? So you don't need to read this, but just be aware that there are commands that you can explore those libraries, and that's pretty much what IDEs like Jupyter Notebook, or let's say Visual Studio Code, they use for knowing, like when you press Control Space, that's what they kind of run in the background, okay? So now let's import the print. I imported already, so I'm not importing again, and then I'll run the next command. Okay, so this is pretty much saying, we confirmed already because we imported the NumPy, but this is showing like where it's installed and things like that, okay? And if we want to see that same dir NP but in a nicer way, we can see here like how the command, the libraries inside the NumPy, and that's what that command is for, okay? If you are being able to run these commands, it means that your environment is okay. So you guys are good to do the activities, okay? Any questions regarding this? Okay, let's move on then. So here on the AA equals NP a range, what we are doing here is we are creating an array in NumPy that has 1,000 values, like from 0 to 1,000, but not including 1,000. So we have a 999. That's a common in Python. When you do range, they also don't, the last number that you do is not included on the array or in the range, and NumPy follows the same pattern, okay? The next command is np shape. This one is for understanding the data. Remember last class that we talked about data bias and the risk of that because you don't know the data and all that stuff? So a good amount of work when you're working with machine learning models is understanding the data. So these functions pretty much for help you out to understand the shape of the array that you are working with. And in this case, that the array that we just generated has one dimension, and that dimension has 1,000 values, okay? Now let's create another one and see what we have there. Mean here? That means that we have 1,000 values in the shape of one dimension, because it's only showing one here, one value here.
So one dimension.
Yeah, imagine it. Do you know matrix like math? Matrices, okay. So matrix, when you have only one dimension, that's pretty much an array, right? Only one line. So this is pretty much saying the shape of this matrix is one line, because you have one dimension and that has 1,000 values. Okay? Great. So next, the NP range, they follow the same pattern of the range of Python. And what those parameters do is that they say you start from 1, you stop at 100, don't include 100, and increment the values by 3. So we are creating the array based on these conditions, and we are getting the result of 1, 4, 7. As you can see, we are incrementing by 3, and as soon as we reach, we're supposed to reach 100, but we don't reach 100 because the last value is not included. So that's why we stop at 97, okay? So that's the array that we are creating. And in NumPy, remember last class I mentioned about machine learning using a lot of floating numbers. So NumPy has the support of creating arrays with floating numbers as well, okay? So that's what we are doing here. We are incrementing by 1 decimal value, okay? Until reaching 1, values between 0 and 1. Alright? The next, ones. So, what this does, it creates a matrix with the shape that you specified in the parameters, and this matrix only contains 1 values, okay? These matrices, they have interesting properties because, as you know, when you multiply any number by 1, you also get the same number. So sometimes you need to run certain formulas that requires this kind of behavior. So that's why NumPy has those functions ready for you to work with. And these ones, like the shape and all those, you guys feel free to do the print screen. Like go to the snipping tool and start to doing the activity. So you can save some work that you don't need to do at home, you know. And when you save, just remember, make it activity 1, your name, and just paste it there, okay? What else? Let's go back to the content. So we are back to the ones. I mentioned, like I kind of gave a spoiler, we have shapes that we can specify, but we also we have the function called shape that we can identify what is the shape of that matrix that we are working with. Because we assign this matrix as ones and with the shape 3, 3, when we try to read the shape of that matrix, we get 3, 3. And what does this number mean? Like the previous example, since we have 2 values here, it means that the matrix has 2 dimensions, and they have 3 values on each of those dimensions. So it's like a squared matrix. Okay?
Why is it one decimal point?
Okay, that's a good question. It's because this is not really an integer. It's way, like remember that neural networks and machine learning models, they use a lot of floating points. So NumPy kind of assumes that you're working with some sort of floating points. So they provide that one dot to say, hey, this is 1 with 0 decimals, and it can work as a float, if you want, or a double. Okay. Okay, that's good. What else? We also have the zeros. So let's say you want to have a matrix that has 0 values inside. As you may know, if you sum anything with 0, you get the same value. So this could be used for certain operations that you might work with matrices. And we can also check the shape of that new one. As you can see, is different from the first example. And here we have 4 rows. The first dimension is usually row, and the second one is column. Okay? If you work with 2 dimensions. There is also this function called I. This one is really interesting because it creates a matrix that has the size that you specified, a square matrix, and creates ones on the diagonal. This one they call I because if you look sideways, it kind of looks like an eye of a cat. So that's why they made it that way. But why they created this function? It's not just to look pretty, right? When you have this kind of matrices and you do matrix multiplications with other matrices, you actually have the same property as 1 and 0 that I was talking before. You have the same matrix as a result. So this is a really important property, and that's why they created this function, okay? And as you can see from the shape, is a square matrix 4 by 4 because we specified 4 here for the I, okay? Now, let's say we don't want ones. We might want something different for whatever reason. So as you can see, the diag, which comes from diagonal, it's saying what are the values for the diagonal here. So in this example, I provided an array with the values 1, 2, 3, 4. So NumPy was smart enough to create a matrix based on 1, 2, 3, 4 in the diagonal. Okay? You might want to do it with other kind of numbers for whatever reason that your researchers or yourself found that are interesting for your problem. So as you can see, the shape for that one is also a square matrix. And that also works with, we use the example of NumPy, but that also works with not NumPy arrays. This one is like a standard Python array, and as you can see, it works as well and also has the properties of a shape. 4 by 4. Okay? So those are some basic operations for creating arrays and kind of working with them or understanding how they are. Do you guys have any questions regarding this content? No?
Yeah, actually. So can you explain so the NV dot range 100 to line number 5.
This one, right?
Yeah.
Yeah, so this one is saying you start from 1, stop at 100, don't include 100, and for every element goes 3 by 3. So if you go on, you're starting on 1, right? The next one is 1 plus 3, so that's 4.
I get that one. The next one?
Mean this one? Okay, link space. So this one is kind of saying you start from 0 and on 1 and make your like increase, but it's not 110%. This is saying like this function, I believe it receives an integer. So in order to represent the integer, they are making like 1001. It's like the decimal, and then you're incrementing 0.1 per interaction. So from 0 in order to 001, and then go 002. That's what they are trying to do here. If you change this for, let's say, 11, probably that will show 0, 01. You know what? Let's provide this example. Let's not talk about probably 0, 01, 02, 03. You see here? If you want to make instead of 2 decimals, 3 decimals, it would be like this. You know? That's how it works. You don't need to go too deep. You need to understand that they exist, and that's kind of how this function works. So a way of comparing them is like the lin space, you're working with floating numbers, and the arrange, you're working with integers. That's a way of seeing it, if that helps you. The lin space, usually you're working with floating numbers, and the a range, usually you're working with integers. Is a way of seeing it. Does that clarify? Okay, yeah, you got the hang of it. As you use, you'll learn it. For now, for the activity here, I would suggest just run the commands, experiment yourselves, and make the print screen so we can follow the agenda, you know? Let's move on then. Okay, so next we're going to talk about random numbers. So I'll even skip the help. If you want, you can run the help here, so you're gonna understand how they work. But the way to use them is that they NumPy, they have this module called random, and they have a bunch of functions inside that they deal with random number generators. So if you run rand here 100, you're gonna create this array of 100 values that has a random number generated by the NumPy, okay? Usually, when you're working with random number generators, they have values between zeros and ones, and that's because the way they are built inside, they kind of have some probabilistic inside, and when you need numbers that are outside this range, you run some math around it. We are not going to do this math here from my belief, but just be aware that there are other ways. And also they have other functions that they kind of break this rule. So let's say this one, if you will make show the N4 here, and not necessarily has ones and zeros, and this one has negative values as well. Okay? Why do you might want to do this? Yeah, sometimes you want some sort of data that is random, and you want to test those random cases. Because something in machine learning that's really common is you want to do better than a random case, right? So that's why the NumPy has those functionalities. They also have this random seed. What that does is that you can set a seed in your code, so you can kind of reproduce the same result over and over again. So let's see how that goes with these few examples. Like the values, in this case, they are different because they are different functions. And another thing that's cool about this is that you can create in those random numbers not only as arrays or whatever, you can create matrices with them. So in this case, I'm creating a 2x4 matrix. As you can see, I have 2 rows and 4 columns. Right? Another function that's really useful is foo. What that does is that creates a matrix with the shape that you specified with whatever value that you want. So in this case, it was 7. So we have a matrix 5x5 with 7 as the value. Okay. And the last thing that I'd like to talk about is NumPy and some arrays, like how to create them, is that they have this empty array as well. This kind of represents what would be a matrix with 0 dimensions. Let's call it this way. Okay? And if you're curious about the data type of your data structure, you can always go and type dtype. That will tell the type of your data structure. So for the example of 7, because we provide a 7 as value, 7 is an integer. Here, the Python, I'm not making 7 dot. So that is returning integer here. Meanwhile, the random numbers, they are float, because as you guys saw, they are decimals, right? And that's the standard type they use. Okay? Any questions regarding this topic? And yeah, reminder just while you guys are doing, remember to print screen as well, just for the assignments, and save you guys some time at home. Okay? If we don't have questions, let's move
Yeah.
on. Do you?
Yeah.
Okay.
So what about this seed function?
Okay, so the I think it's easier if I show the doc, so I can show you how that works. You reset the random state of the instance. I don't know if you have you ever heard about seeding games? Let's say the top example that come to my mind is Minecraft, because you can seed a word. I don't know if you ever heard this term. The reason why they have this term is because in math and in these libraries of random, you can provide a certain value that and that value is called the seed, that you make the random number generator works in the same pattern over and over again. That's useful for recreating certain states and certain experiments that you are meant to be random, but when you are in the real world, you don't want them to be the same, right? You want to keep testing with random values. So the seed in the random is usually that, and when you in the Minecraft world, because it's a random number generated word, when you provide the same seed, you kind of provide the same word, and the reason is because of that, because the random number generator is behaving the same way. Okay, and that's how you do it in NumPy. Okay, so yeah, let's go for the next activity then. And just a reminder, when you guys do the print screen, remember to add the number. So the last one was activity 2. And now we are going for the activity 3, okay? That helps while correcting, and I think that's gonna get your grades faster. Okay, so now we are going to talk about time it, okay? And that's one function from actually from Python, and that is meant for like a stopwatch to verify how long your code took, okay? So let's start with this example here. We are going to create an array and play around with it, okay?
Do we have to insert time bit?
You don't need to install it. That's part of the standard library, so you don't need it. Don't worry about that, okay? The only libraries we are installing today is NumPy and Matplotlib, which is going to come next after these activities. Okay? So yeah, this is the array. We are creating the array. Let's see how that array looks like. As you can see, is a NumPy array with 0, 1, 2, 3. Well, now let's make a range here. Like this is standard range from, as you can see, from Python. And then let's see the structure. Here, as you can see, is a range. Range usually you do a structure that kind of says you have values between 0 until 999. It's similar to the range that we worked on NumPy, but this one is like the standard Python one, okay? So if you go on position 0, you see 0. If you go on position 500, you see 500, etc. Okay? A common use for those ranges is to run for loops. So in this example, we are going to do something really interesting in Python word, that you can run for loops in line. Okay? So here we are doing the power of 2 for every I in the range that we just defined. So we're going to make a power of 2 for 0 to 1000. Okay? Not 1000, because the last one in return includes is 999, but you guys got the idea. So this is the result. For this one, you don't need to print screen everything, just a few samples is enough. If you print just from here to here is more than good enough. But the point of this is this code is kind of using standard Python code, and that's not actually the most optimized one for large amounts of data. So let's run an example here with time it to measure the time that we take to do certain things with certain structures, okay? So this one is kind of what we've done in the command line, but now we have a string that represents the commands that we ran. And the way to make a string to have more than one line is to have these 3 quotation marks, single quotes actually. If you just copy, you're gonna be fine. You won't have issue, but just to be aware, the reason why you are making more than one line is because those quotation marks. Okay?
Sir, for the assignments, all we are doing is copy pasting the lines in the picture.
Yes. Yes. Because you guys need to get familiar with the commands, and if you guys have any questions, yeah, feel free to ask. So I'll help you guys out. This is kind of introductory course, so I don't want to go and say, do some formula in NumPy and crazy things like that. No, we are trying to go But even though making easy, as you can see, is getting dense, and the knowledge keeps piling up. So try to understand those commands, because most likely I'll bring something like what is the result of this code on the midterm or something like that. That might come. I don't know yet, but yeah. Okay.
So what if you wanted to write the string on a single line? Would you use double quotations?
You could do that, but that would make your life harder. So that's why we're making this. And an example to see how that would look like in one line would be this.
Okay, single quotation.
You can make it double, single, yeah, but Python kind of supports both. There is a difference, but let's not go there now. Okay, so now let's import Timeit. We don't need to install it, but we need to import it, okay? And with that, I not even run this one because this takes really long. But I'll run, you know what? I'll do this example because I showed on the last class. I'll run this command, okay? I ran, and as you guys can see, it's stuck. If you guys run, we'll be stuck as well. After a few minutes, we'll get unstuck. If you guys want to just keep it following, you can open a new window and run the same commands. So you're gonna be on the same state, but this is stuck. And why is it stuck? Because it's using a standard range from Python. So do like the power of 2 1,000 times is enough to break the interpreter of Python. So while we wait, I'll just actually do what I suggested you guys do. I'll open a new window and run some other comments so I can show you guys what I mean. Of course, this is not going to work. We need to run Python first. So now we can do the same commands, and we can try something new, like let's say this guy here. Let's see if it's going to work. Time it's not defined, so we need to import it. And even when I'm playing around with this stuff, the thing is still running on the background, and it's kind of stuck, as you can see. So import it. Now let's run other commands here. Like the number 10, you can run 10 times. Ignore this one, I copied by mistake, but focus on this one. When you add this number, it's pretty much saying how many times you can run that, and then inside the Timeit, it tries to run the commands in parallel. So the reason, that's also another reason that's taking so long here. It's just stuck. And here things start to get faster, right? So it's take you less than 1 second, things like that. But now let's try with the NumPy structure, okay? So make a variable, set up L, and let's try to do the same thing, but now with the NumPy code. As you can see, we didn't wait anything. And the reason for that is because NumPy kind of does things in parallel already, and it's insanely fast. Even if you compare in the same situation, this example here, it was like more than 100 times faster. Okay? And the bad boy from the other The window is here still. It took a while, but it got some results. Okay? And what is the important thing to remember with this example is the NumPy is way faster than standard libraries of Python, okay? And not just for some operations like this one, but we can do fancy operations like this. And this runs like 100 times. 100, no. Yeah, 100,000 times. And because we are using NumPy, it's not going to break my computer. As you can see, it took less than a second.
So what is the time exact? So what is the method of time? I mean, library, that's kind of a library, right?
Yes.
And so what is that? You know, what exactly the purpose of this library exactly? What is
It's like a stopwatch. Imagine you're waiting for, you're in a race and you have the stopwatch, right?
No.
So the timing kind of does that with functions in Python or code in Python. So in this example, I'm running, remember the setup that we've done here? We use NumPy and the range here,
Yeah.
and then we do some certain operations with this range, like this. This is kind of the code that we are running inside the time with this setup.
Oh, it must be written, so between the quotations, right? The double quotations.
Yeah, it's a string.
So it's kind of string.
Yeah.
So
It's-
anywhere, you know, we define timex, so we have to use the double quotation, and then, so we write the commands of the range, we define our range inside the double quotations, right?
Not just range, it's more like
So any commands.
any commands, yes.
Yeah.
That's a way of seeing. So this would be like the command itself. This is like a setup. So here, as you can see, we have the variable L. Where is the L? It's here. So we are doing a setup here. Probably don't even need this one, but yeah.
So what is useful for it?
They use it for it is like I said, it's like clock watch, like stopwatch. You want to
I mean,
check
in a
how.
real project, you know what I'm saying?
In a real project, I'll say like it's not even machine learning. Let's say you have an API and you run that on Flask.
Okay.
That's a really lightweight, or even Django, like the Django itself, right? And you want to know the average time that you take if 1,000 users hit your API, like a load test. But it's not a load test because you're running that code in parallel.
Okay.
So it's more like a way of measuring how reliable your system is and how fast it is depending on the situation. So that's how we usually use time it. It's literally to time it, to time how long your code takes. So the purpose of this example is just to time it, the difference between standard range and the NumPy range.
You
Okay?
can testify the time of some specific process, you know, by this way or not?
In theory, yeah, you can do that. You need to look at the documentation, but yeah, in theory, there are ways.
No, this is one of the usages.
Yeah.
How do you get out of setup? Like, I input the setup command, and it didn't.
It's not a command. You're setting up a variable. So in this example, you can just copy the example that you have here, and you do this. And when you paste this, we are saying, hey, I'm going to create a variable setup with this string. And the string are pretty much the commands that you want to run inside the file. Does it make sense?
Oh yeah, I just put the setup button, and I thought like it was gonna return me the other.
No. It doesn't return. If you want to see how that looks like, it's like I mentioned, you can type setup, which is the name of the variable. Every time that you write just the name of the variable, you see what is inside. So in this case, there is this string. it's not that useful because that's the string that we set that up, but it's a way of seeing if you want to debug. Let's put it this way.
Okay, wait, after you wrote that, how do you go back to Python, writing Python commands?
They are Python commands. Yeah. 3 single quotes. If you try to type, yes, 3 single quotes is going to say, hey, the string stops here. Yeah. It starts with 3 single quotes and it stops with 3 single quotes.
Yeah, okay.
Yeah, thank you for helping me out.
Excuse me? So, before now you didn't have NumPy? Because you said import NumPy as NP, so before now, what were you using?
You mean this?
Yeah.
No, the catch is, like our friend said, this code kind of runs in a different process on your computer. So because of that, you kind of need to declare your variables inside there again. So that's why we have the import NumPy as part of the setup process.
Okay.
Make sense?
So every time you are trying to,
No, not every time. It's just for this time it's example. This time it's just the way this time it works.
Last question. Can you guide us to where we can find like this concept?
Yeah. That's easy. That's it. When you go to the activities here at eCentennial, in this case it's activity 3, so you can come here and look at the reference. Okay? So if you want to go deeper, you can come here. Like they give crazy examples about it. Like you can go wild if you want. Okay? So that's pretty much what I was trying to show you guys, and you can go wild with these commands. You can run on your leisure if you want, but the point here is that NumPy library is way faster than standard Python. Okay. Now let's go to the activity 4. Okay. And remember to do the print screen, so like I did on the previous class, like activity 3, did some printing here, show the time it, and then activity 4. Okay?
So we don't have to put all the codes?
Not if they are kind of repetitive. Let's put it this way. Aim for all the codes, but you don't need to, let's say, like this one. This is the whole list of 1 to 1,000. You don't need to print everything, but if you print most of it, that's fine. Like in this case, I end up printing everything, but yeah.
Okay.
The important thing is that you ran the code and you got some results of it. Okay? So try to do that. Okay, so for activity 4, we're gonna learn about indexing and slicing. This one is interesting because it's kind of flashback of the assignment 1. You guys played around a little bit with the range and how the indexing worked on the standard Python. But now let's talk about how that works on the NumPy world. Okay? So let's see which thing is the one that has the most data. I think this is the one. No, close to this one. Okay. Yes. Can you speak
We
louder?
gotta change the values for that sign. Change the values.
Some of those will change because of the random, for example. But try just to run the same commands. The values itself, it don't matter. What matters is that you try to run and then you got some results from it. And you understand those commands.
Oh, yeah. For example, for the first line, as you can see, like 0 and 56, right? This is the range, yeah? And so we can, for example, we can use the same values or we can change it. So most of them are going to work for you, right?
I get what you're saying. I would, for these arrays that we create, I would say keep them the way they are, because especially addition of this example, we're gonna have some really specific values that we are going to play around, like these guys. So in order to avoid confusion, not only for you guys, but also for me, let's keep it the same values, okay?
Oh, okay, same values.
Yeah, because we are gonna analyze, but I'm doing per time so I can explain you guys. But that's fine. Okay, so now this part we kind of know how it works. Is we are creating an array of one dimension with values between 155, right? But something interesting with NumPy is that you can reshape the structure that you are working with. And that means that in this example, I can make a matrix with 7 rows and 8 columns. So I get a matrix like this, okay? That's what reshape is doing. And you can do also the other way around. If you want 8 columns and 7 columns and 8 rows, you can do the same as well. You can put in any shape that you guys want for whatever problems that you guys need to solve. So now let's create another example, and let me show what I mean. In standard, we have an array like this. That's how it goes. And we can reshape, like let's say a square now. So we have these values until 36, and we can make a matrix 6 by 6 here, and as you can see, it becomes a square matrix.
And these are random numbers.
No, this one, when you use range, they work like the range of Python. They go from 0 to whatever
0
value.
to like the number we have defined.
Minus 1, the number we define. Yeah,
Minus 1.
yeah, yeah. Because we don't include the number we define.
Okay.
Okay, so there is that. And why we are doing this? So we can explore some operations with matrices, some slicings and indexings. This is something that standard Python also have, but this is something interesting to you guys to check that out. Let me see, I think I didn't declare that variable. I did not, B66. Yeah, I did not. My bad. Now it's going to work. B66, that's the variable we are going to work with. And we can access some values that are really interesting inside that thing, like this one. So what this indexing is doing, and this is really important if you work with even Python, standard Python, and you are working with matrices, is for the row 0, which means the first row, we are going to get the values from 3 to 5, index 3 to the index 5, excluding the 5th one. So let's say 3, 0, 1, 2, 3, and then 4, 5, we are not including 5, so it's 3 and 5 the results, and that's the results we are getting here. Okay? So that's how this kind of notation works. You have the first dimension, comma, second dimension, comma, n dimension, whatever amount of dimensions that you need. And you can do some funny operations like this one, from the 3rd index until the 5th, excluding the 5th, or whatever number you want.
The 0, what does it represent? The 0, sorry, I missed that.
Yeah, so the 0 is the, like, 0 comma, so that means that is the index 0 of the first dimension. In a matrix, it is usually the row, right? It's row columns. So the first row, I'm going to look for the columns 3 until 5, excluding the 5. So column 0, 1, 2, 3, 4, 5, excluding excluding 5. So that means those two values. Because it's 0 for the first row and then the columns next. Okay? So that's one thing that you can do. Another thing that you can do that's really interesting, I gotta say I don't remember other languages that kind of do that, is this one. So what that does, the same operation you can do for any of the dimensions that you're working with. And that means that here, we're gonna start from the row, the fourth row. The fourth row, no. The row number 4, okay? We start from 0. And then we're gonna fill everything until the end. Same for the column. What that means, if we go 0, 1, 2, 3, 4, 0, 1, 2, 3, 4. So we are getting all the values that are here. That's how we are getting 28, 29, 34, 35. That's how you see it. So it's the first criteria is the row. So we are excluding everything, and we're gonna start from the fourth. 0, 1, 2, 3, 4. Same for the column. So we are getting this piece. Okay? That's how you slice your data around like a ninja. Samurai or whatever, and you can work with that. Okay?
Okay, so supposing it was like 5, you know, like 5, 5, or
Yeah, that's since you brought that example, let's see what happens. Just let me show only this one.
The same index, like on the route, like just a number 4. Yeah. Number
That's
5.
where
I'm
you
sorry.
start. Yeah.
So I have a problem like over the second one, the second like array, 34 and 35. Yeah.
Oh, this one?
Yeah.
So what is happening?
Not that one. So no, down here. Yeah. Like a 28, 29, 34, 35.
Oh, you mean this?
Yeah.
Yeah. So what is the question?
How it's gonna work?
How it's going to break?
How
Ah,
it's gonna work?
work. Okay. So that's like I was mentioned before. Like if you let's print the p66 again. That's the matrix we are working with, right? So here, what we are doing is we are saying Python, get me the index 4 for the dimension 1 and 4 for the dimension 2, but not, I don't want just the 4th one, I want everything after the 4th one. Yes. So if I go 0, 1, 2, 3, 4, okay, I want the 4.
And the 4.
So I want this and moving forward. So I want the last 2 rows.
Yeah.
Now I then need to check the column. 0, 1, 2, 3, 4. I want the last 2 rows. So the last 2 the last 2 columns. So I want the last 2 columns. So the last 2 rows with the last 2 columns, we get the matrix that are pretty much these values here. So that's what this is for.
Why not 28 and 29?
Because we are not doing this, like there is a difference. Can you see the difference now? When we make a column like those 2 dots and we don't specify a number, we want everything after that. If we remove the column, now we get the example you're
And it's
mentioning.
kind of like just make square, right? Make a square.
In this example, yes, but could be other shapes, like it
Yeah.
depends on the data that you're working with, right? Make sense?
Yeah.
I think you can try number 3, like column 3. We can see maybe more clearly.
Yeah, if you guys want, I can do that example as well. So it's like expanding now because we have one more row and column to work with. Okay?
also, hey, sorry, can you take off the colon on the column
other one.
Can you take off the double dots on the other side?
Ah yes, that I'll bring examples of those. I kinda did already, but we're gonna have a few more examples regarding that, okay? Okay, so that's how this one works. Now let's see how this one works. Okay, let's go to the B66 again so we can see the full example. So here, what are we doing? We have the columns now, and we have no values. What that means is start from the beginning and end on the end. That's pretty much what it's saying. So for the row, go for every row. Here, it's specifying the column number 2. So 0, 1, 2, we are getting the values from this guy. So that's why we are getting 2, 8, 14, 20, 26, okay? So you can also specify no values, and that's pretty much represents the whole dimension. In this case, the dimension that you want to keep is the row.
The first one is X and the second one is Y. Yeah? In other words, we can see. So X, it plays the role of the row, and Y, it plays the role of columns.
Yeah, if you want to name them like that, yes. I would prefer A, B because X and Y could confuse you with math terms, but yeah, it could. I think you understood. So that's another example. Let's move on with this one. This one's a fancy one. Okay, so why are we getting this? What is this, right? So remember the first value that represents where we start to count, right? The second value represents where we end, but we don't have an end here. It's not showing. You see here, there are 2 columns. The third value that represents the increments that we are having. Okay? So what this is saying is get this from the second row all like even amounts of elements, like every other element. So let's go with this. For the second one, 1, 0, 1, 2, right? So every other, like, so that would be the fourth one and the 2. Okay? So we have these 2 rows. And we can even confirm with this 12 and 24. Okay? But now the second one, on the column, on the dimension of the column, we are specifying start from the beginning and at the end, but get every other value because we are incrementing 2. So how we are going to do this? We're going to start 0 plus 2 plus 2 and then end. So 12, 14, 16. 12, 14, 16. And on the 24th plus 2 plus 2. Then we are getting those values. You see? So if you are familiar with Python, you've seen that on for loops because they use ranges there, and that's kind of how ranges work. You can change the increments, but in NumPy they also support that on arrays and how you interact with arrays and manipulate them. Okay? So that's how you read this. So as you guys can see, it's a really powerful tool, and you can do a lot of good stuff with it. Okay, and now for the sake of example, I'd like to show in the Python world, this is a standard array. We can actually do that with standard arrays as well. So if you make just column, you get all the values. If you make starting from 2, we're gonna start from 2 and finish. If you want to skip 2, right? Starting from 2, we're gonna have 3 and 5, yeah, 0.
Can we use tuple?
Huh?
Tuple, can we use tuple or no? So instead of list.
tuples because this is really good example for our NumPy because it manipulates stuff, but probably you can use in tuples as well. If you want, feel free to try. I think it works. So what else? 2, 2, 2, 2, and this one is the example of like we mentioned here, from the beginning to the end, skipping 2. So now we are getting the odd values because we start from 0, right? So 0 plus 2 plus 2. Those are the values. Okay. Now let's see the shape of that B66 as we made matrix 6 by 6. We have this shape, and if you want to get any value from that matrix, we still can do that. Okay? Yeah, this one is easy to read, right? Column, row 4 and column 5. This is standard coding, but the fancy stuff are there as well. You can use as your leisure, and those are really useful for processing the data. Okay? Any questions regarding activity 4?
I'm sorry. I can get the last one.
I mean, these ones?
Just the very last one. The 6 6. B6 6 6 6 6. Yeah.
Okay. So B66, B66 is the matrix we are working with, right? So when you do a shape, you say what are the values that they have on each dimension. In this case, we have 2 dimensions, 6, the row and the column, and for each dimension we have the values 6 and 6, like the amount of data that we have on those dimensions. Okay?
What about the next one?
What do you mean, the next one? Which one?
4 5. B6 4 5.
This is just getting the position. This is standard coding. If you go to the position 4 and 5, so let's say position 0, 1, 2, 3, 4, 0, 1, 2, 3, 4, 5. So that's 39. Okay? All right, let's move on. And again, do the printings and yeah, try to save us some time. Okay, for the next one, we're gonna talk about simple arithmetic operations, okay? And also transposition. So we're gonna play around with our friend, range. We're gonna declare it and see what we can do from there. So when you do a range 5, we have an array of 0 to 4. And in NumPy, they have a lot of built-in functions, math functions, which includes the scene, the log, and something interesting regarding the log is that it's smart enough to not break when there is a division by 0. So the log of 0 usually runs errors, but this one just provides a warning. We have X as well. This one is not as intuitive, but I don't know if you guys heard about the Euler number. This guy here. That function pretty much calculates that at the power of the number that you're passing to that function. For this course, just know that that's an important function and it's there. But if you run into real world problems, that's what it's about. So that's, if you need to talk about it, feel free to talk about it with whoever needs that function. We have the I as well, that we talked already, right? And we can run operations on matrices as well. That's the fun part about NumPy. So instead of doing a for loop, going one by one, we can just run these operations from NumPy in one line, and you get the results. So as you might know, the scene of 0 is 0, so that's why we are getting this matrix full of zeros in an I kind of matrix. If we do the log, we are going to get same thing, but with minus infinity, like we've seen here. The log of 0 is minus infinity. And if you want to check the EXP, you also get EXP on the power of 0, that's 1. Like any number of the power of 0 is 1. So that's why you're getting this matrix with random numbers at the beginning, at the middle, and these ones around. Okay? So as you can see, these operations, they work in the whole matrix. You don't need to do any sort of for loop or anything like that. Another cool thing about these functions on NumPy, they work in cascade. So that's how things can get complex. Like in this example, we are going to create an array from 0 to 8, and we're going to reshape it to a matrix 3 by 3. And we get this result. Okay? So that's how you cascade things. And you can run other kind of functions in this kind of structures of matrix. So the try u, that means that we are keeping the top of the matrix and making zeros on the lower part of the diagonal. That might be used for certain operations that you might want to do. If you have symmetric data, you might want to cut half of your matrix because they are the same values. That's a possibility. You can do the other way around, like cut the top half. It's your choice. It's there for you to use. You can keep just the diagonal and manipulate that in a form of an array. And you can transpose your data. For the spreadsheet users, you've probably seen that. You're just flipping your matrix around. So instead of having what we had before, 0, 1, 2, 3, whatever, now we have 0, 1, 2, 3, like the columns and the rows, they are flipped. That's what the transpose does. Okay? Any questions regarding this? Okay, let's move on then. Now let's talk about basic reductions. This one, a way of seeing this is like SQL, and remember those functions that you use on the GroupBy? That's kind of way of seeing this. They are like aggregation functions or ways of reducing your data to a more meaningful value depending on the situation. So continue on our matrix C, we can sum the values. So in this case, we're gonna get the value 36. We can sum values on based on the row, keeping the row, I mean. So in this case, you have 0, 3, 6. If you sum everything, we have 9. 1, 4, 7, we get 12, and so on. Is the dimension. So you're specifying which dimension you want to, in this case, keep. So you want to keep the rows. You have 3 rows, you want to keep 3 rows. So that's why he's doing the sum of the columns. Okay? In the next example, we do the opposite. We want to keep the columns. So we get this result. So we are keeping the columns, so 0, 1, 2, we get 3, 3, 4, 5, we get 12, so on. That's how it works. Okay? So this is like the dimension that you're choosing in order to run this operation. Okay? You can do some crazy stuff with NumPy, like these. Remember those indexing stuff that we're doing? We can do a sum like this. This is saying get the first row, all the elements. So we can do a sum on that because that's part of NumPy, and the functions they are there. You can use them. You can do other operations like minimum. Again, you do maximum. And just for those who don't remember what this means, I can show the data that we have here, 0, 1, and 2. Basically the first row, like I mentioned before. The first one is the row, and the second one is column. Because we have the 2 dots representing the column, it means get everything, so get all the values related to columns, right? And keep just the first row. So that's why we are working only with this. And we can run operations on the top of it.
Sorry, what do you mean get all the values?
Like, remember when we iterate through the matrix, like rows and then columns? For the columns, we're keeping all the values. So we're working only with the first row and all the values of the first row. So 0, 1, and 2. Okay?
Okay, so you're just printing the first row.
I'm slicing the matrix so I can run operations on top of it. So here, I'm slicing and summing. I'm slicing and minimizing. I'm slicing and maximizing. And here I'm slicing just to show, in case you guys forgot. Okay? You can run operations on matrices as well. So argmax and argmin, we get the maximum value of that matrix and the minimum value of that matrix. So 8, as you can see, is the maximum value here. 0 is the minimum value. We can do like these ones, they are pretty much following more examples of the slicing. Like here is the second row with all the values of the column. I'll skip that one for the sake of time, but I'd like to talk about this.
So I have a
Yes?
question. So the part that it said like get the maximum of, it doesn't specify which row or like which column. It just says C dot argument main.
Yes, the argmax is for the whole matrix.
Oh, okay.
Yeah, when you see this arg, it's usually for the matrix itself. So another thing that I like to mention is like it's you can cascade functions, so you can do something crazy like this. Here we have the matrix, we have a transpose, we have that syntax that we get just the first row, and we want the maximum value. And what does that look like? It will look like this. Number 6. Why? Because when we transpose, we make it this. And when we get the first row, we get this. So what is the maximum value of that row? Number 6. Okay? So you can go wild with these functions. You can go cascading them and do a lot of crazy stuff if you want to. Okay?
Sorry, can you explain what transpose means? I think.
Just flipping. Like if you see here, this is the original, this is the transposed one. It's like if you see the diagonal, the values they change. So every row becomes a column now, things like that, in a new matrix. Okay, so I'll skip some of it, but actually I'm not skipping, I already explained these ones. They're just more examples, but for the sake of time I'll just let them go. Now let's talk about booleans. Booleans, they're super important because that's how you represent if something is valid or invalid. And when you work with booleans, they have operations just for booleans. The first one we're going to talk about is the OR. What is the OR operation? We are checking if all the values are true. In this case, it's returning false because the array that we have it has true, true, and false. So since one is false, not everything is true. Okay? For any, it's kind of the opposite. If one is true, everything is true. So for any value that's valid, you're gonna get a true as a response. And we can go wild and do the cascading thing. And in this case, just for the sake of showing you guys this is returning just the value false. So any of something that's just false is going to be false. Okay?
It works as and or, right?
They work like and or, yes. Any would be like the or and the all would be like the and. Yeah. But for everything. It's like a for loop for everything.
Yeah.
And we can go crazy with that actually. On the example here, the all is not should be it's true because we're stopping at the second one, which means that we have only these two values of true. And now we're gonna explain why those matrices, those zeros and ones are so important. We're gonna create a matrix 100 by 100, as you can see here. And we can run operations on matrices as well. So if you run npn of a0 that's different from 0, because everything is 0, this will become false, right? You don't have ones left. If any is equal to 0, like you're gonna get true. But something funny about this is that if you compare a NumPy structure with something, you get a matrix of booleans. And what does that mean? That means that you can do all those sorts of operations using that. So let's say you want to check if a0 is equal to 0 for all the values. And we're gonna get true because this matrix is only made of zeros, right? If all of them are different from 0, we're gonna get false because all of them are 0. And these operations, you can go wild. You can make a lot of conditions here, so you can manipulate your data any way that you want. Okay? So just be aware that they exist. And also there are other functions as well. I won't go through all of them. You can follow them on the exercise, but they kind of follow the same idea. But these functions, they are the statisticians functions, like they have the median, they have the mean, they have standard deviation, and etc. And you can do things like choose the axis, or you can do things like for the whole matrix, like we are doing before. Okay? So that's what I want to talk about in this part. Yeah, I don't want to go too deep on that because of time. Any questions regarding that? No? Okay. Yeah, let's move on then. So I really want to talk about now is the matplotlib. And let's try to go through activity 1 together, and then the rest you can bring it home if we don't have time. So first, we need to install the matplotlib, like we did for the NumPy. Okay? So in order to do that, open a terminal, run this command of pip install. That's the terminal of your computer. That's not the Python window. So just be aware of that. And then you can install through here.
That's for week 3? Or is that?
Week 2, still week 2. But now we are going to the if you see these arrows here, like on the previous one we had the NumPy, and then now we have the Matplotlib, okay? Okay, once you guys have installed, I'd like you guys to copy this code on whatever IDE you guys like to use. I have the Notepad++ installed here. And then we are going to run this code. So just save it on your desktop. In my case, I saved as activity1, as you can see here. And then open your idle. This case, I'd like you guys to run the shell, like the real shell, because they have the option of loading files through here. Okay? If you have problems opening that, if you go on the previous NumPy thing, you can run this command, python-m idle lib, that does the same thing, as long as you run that on the terminal. So let me show it to you guys. That opens this, okay? As soon as you guys get here and you saved the activity1 of the Matplotlib, I'd like you guys to open that file through this terminal. Okay? So that's what we are going to see. And then you just need to click run.
Can we use VS Code for this?
If you have it available, yes.
So what should be the what's it called? Is it NumPy or what's it called?
As long as you know what you're doing, I'm happy with any.
Like when we're saving the file, what should be the last two letters, whatever it's called?
.py, the extension, .py. Yeah, .py.
So where do we open the file?
Hmm?
Where can I find the activity file?
This application? Is that what you're asking? Like, is this one?
No, I open the node shell thing, but I'm not sure where can I just copy the
Okay.
code and the.
You mean this? You're in Mac, right?
Yeah,
If
no.
you're in a Mac, yeah, you might need to run like this. So you go here, file, open. Yeah. Then go to your desktop. If you save the file. Okay, so I'll go again. On the activity1, you can copy this code and go on whatever ID you like. In my case, I'm using Notepad++. Save this. I would recommend a desktop so you don't get lost. And save it as activity1. Okay? Once you've done that, try to load that on this shell and see the result. Okay?
So I have to
You can open anything you like. I would recommend a Notepad because that's what I have here. But if you like to use PyCharm, Visual Studio Code, you can use any of those. Just save the file and try to run it. Okay? If you guys have success, it's going to show something like this. And when I get enough confirmation that things went well, I can explain what's going on. All good there?
Should be funded.
I'm sorry, could you show me
You don't need to copy from here. I would recommend to go to Centennial copy from here.
Oh, yeah.
Yeah. The in contents
I don't know why it's not working.
here, matplotlib. Okay. A few problems that might occur when you run this. Maybe a library is not installed. If that's the case, you go to the terminal, you open, run those commands, pip install, whatever the name of the library that's fake. But if everything goes well, you should be able to run. And if you run, you're gonna be able to see this chart. So I'll explain what's going on here. So what we are doing here is we are using both libraries together. We are using the matplotlib and the NumPy, and we are creating arrays so we can plot them. Okay? And that's what we are doing here. The X and Y, we are plotting in a line like this. And the reason why it's looking beautiful like this is because we are doing this lean space. So those are like float numbers. So it can go, instead of going 0 to 1 to 3 to 4, they are going smoothly, so you can see this beautiful line here, like this. Okay? So, yeah, just reinforcing that floating array, right? If you want to try other stuff, we can add this as well, like change this to the new code, and we can okay, you're gonna be able to see some dots here showing the lines. When you do this O is one of the parameters of the plot in case you want to see the true data, right? But it's still at least showing some of this stuff. The activity tree, we can do that in class as well, I guess. I think we still have time. So you can see that you can change shapes of the plot. In this case, we are making a string representing this. Let's say you can make an X as well. It should work. And you can do a lot of stuff related to it. This one, I believe, is going to be a cool one to show as well, just for the sake of example. Like the senoid function, the sim function, that's how it looks like. So you can do charts like this, and that's how usually machine learning researchers, they analyze the data. They keep going for the charts and they find patterns on them. That's how it usually works. Yeah, because it's 10:20 and I want to respect you guys' time, I'm going to finish. But yeah, just finish this activity at home and let me know if you run into any issues. I can try to help.
Do we have the sum results too?
Yeah. Just do your best and follow the instructions. If you have run into any issues, maybe post on the forum so people can help you out. Some students messaged me and they kind of had the same questions. So if you guys post out there, maybe you're gonna help someone else. So yeah, feel free to do that.
And is it used for data science, right?
Huh?
Is it used for data science? And most, I mean, the most, like, the most, which is objective of using it.
You mean the
most common objectives.
You mean on NumPy or
No. I think like, so the shape, you know, it's gonna be drawn by, so, our age by using, like, the pie plot, right? Pie plot.
Yeah, so what they do is they use those charts to analyze the data and find patterns. That's what usually they do.
In purpose of data science. This is the way in which
That's the thing, machine learning is part of data science, so it's hard to say that. It's not just data science, it's just, Yeah, it kind of is. Yeah, you're right.
Oh, I mean,
If you know what I mean. Okay, I got a similar issue. The way to fix this would be just try to open this through that command. Go up. On this arrow. No. Yes. Try to open this. If that works, follow that. But if yeah, no, go to the table. This is it. You can recognize by the arrows. And try that again.
Yeah. So yeah, exactly. The point is like, certainly